Welcome everybody, first session of the day. Thank you for coming. What Tao and I wanted to talk about today was disrupting data discovery. My name is Mark Grover. I'm a product manager at Lyft.
My name is Tao. I'm an engineer at Lyft.
And let's jump right in. The very first question we almost always get in the talk is where are the slides? And the answer to that question is on the first slide. So if you go to go.lyft.com/data discovery slides, all one word, that's where you'll find the slides. One more time, it's go.lyft.com/data discovery slides. Cool, so let's jump right in. What we wanted to do today, we wanted to talk about a few different things. The first one is share a little more context into how the data platform at Lyft operates, then share challenges particularly around data discovery. What does data discovery mean? What does those challenges look like? How did we solve that problem at Lyft? Then we jump into the architecture and share a little more about where we are going in the future with that. To get started, there are a few different kinds of users we serve at Lyft with our data org. The first kind is a well-understood user. Data modelers or BI engineers or data engineers is the same term. These are people who are developing data models for your organization and building dashboards in many cases. Analysts, your SQL-heavy analytical users who are helping drive decisions in the organization. Data scientists, machine learning workload-heavy engineers/users who are building models on your platform. An example of a data scientist would be powering, say, the pricing algorithm or the ETA algorithm in Lyft's case. Product managers, folks who are shipping products of your organization and using data to figure out how those products are doing. General managers, a special category of users at Lyft. These are operation managers, essentially, who are responsible for the health of a marketplace. So imagine in San Francisco area, you have a general manager, and their sole responsibility is to make sure that there are the right number of passengers at the right time at the right place offering rides, and there are right number of drivers offering rides, and then right number of passengers requesting those rides. So keeping the marketplace in balance. Engineers, these are folks who are writing code, shipping code, and seeing how their code is performing as it gets deployed. And the last one is experimenters. This is not a role per se, so this is not a title, but it's a hat that many of these people that we alluded to earlier wear, and these are people who are running experimentation and A/B tests. And these aren't necessarily your standard like red button, blue button tests, but at Lyft they can go all the way to as sophisticated as new pricing algorithms and testing out those algorithms in an experiment, and then using those results to decide whether we go forward with that or not. So to give you a little more context into how we serve these users, here's the high-level architecture of the data at Lyft. So the first example, we'll start from the top left. You have your phone app, you request a Lyft ride, we send a bunch of events. These events follow on to a message bus, which is Kinesis right now, and we are moving to Kafka because of scalability concerns of Kinesis. The other bottom left corner is services. So the ETA service or the pricing service or any other service can also send events. And these events also go to the same message bus. And this is where the paths coincide, and now everything goes to the same pipeline from here. We have Flink that we use to ingest this data from the message bus onto a blob store. That blob store for us is S3. From S3, this data gets loaded into a bunch of different specific data stores that work very well for certain use cases. So the first example that's been historically the case is Redshift, your standard sort of OLAP MPP database. We are divesting our energy from Redshift in favor of more systems that you will see at the bottom. So these are Hive and Presto, which are more the norm now. We store our data in Parquet and S3 and use Hive for ETL. We're actually also using Spark for ETL, and Presto is more for ad hoc querying. We also load this data into Druid for faster interactive query analysis. From all these systems, we use a bunch of different applications. The standard BI applications are Looker, Mode, and the third logo you see there in the form of Infinity is Apache Superset. We have Tableau as well. And then we build custom applications to serve various different kinds of users that you saw in the previous slide. Cool, so with that, we move on to the topic of data discovery. And the first thing we wanted to share here is that this is really a problem of democratization of data. And what we mean by that, lack of democracy, means that there is classes of people, right? So if Tao's been at Lyft for 4 years and I've been at Lyft for 4 months, we may end up falling in a different class because Tao's got a bunch of tribal knowledge that I don't, right? So the sole goal of democratization is to take out that class. That means Tao and I are enabled at the same level to be successful in our roles as data scientists, analysts, engineers. And that's really the true goal. And why did we want to do this? First of all, it makes everybody more productive, right? That means I can join the company and be as productive as a 4-year veteran just in 4 months or even less, right? Number two, it is the right thing to do, right? We want to make sure that everybody in the company is enabled to be successful, and that's why we started exploring the space of data discovery. So what does this actually mean? So say you start off as a new data scientist, and the very first question, I'm using the example of strata attendance here, but think of your worlds, right? Imagine you just jump into the organization, your first question, you got your first analysis task, and you're asking these questions like, okay, I'm going to calculate like strata attendance, but where is this data, and how do I find it, right? And there are usually 2 ways you get about this question, right? The first one is you call a friend, be like, hey Tao, I'm looking for strata attendance data, where do I find it? And Tao is like, oh, go over here and you'll find it. And also, stop bugging me, you're asking me a lot of questions, right? The Tao is nice, he won't say that. But if you're lucky, maybe your organization has a more standard way of doing this, right? And the standard at Lyft before we solved this problem was this GitHub file where we had all our ETL code, and you could do a GitHub search. But you notice on the right-hand side, you have like so much code coming out of this, and you don't really know which one is deprecated, which one do I use, so it's still not very usable, right? But let's say you figured out with your coworker which table to look at, and then you go to the next question. Okay, well, what does this field mean? Like, I see each row. Is this row for people who signed up, or is it row for people who actually attended, right? So you have all these questions about the semantics of the data, and you don't really know the answers to them. So you either ask your coworker again, or even worse, you do this, right? How many of you have written a query like this? Raise your hand, please. Yeah, see, about 50% of the room, right? And guess what's wrong with this query? First of all, you're wasting a hell lot of time writing this query. But second of all, the data infra people are like, man, you're like bloating the load on my database because like everybody's just writing these select star queries, right? So we did a bunch of surveys. The first thing we found out that data scientists at Lyft were spending about 33% at least on data discovery. And what is data discovery? This problem of like understanding what data do I use, where is it, what does the semantic mean, how do I use it, that kind of stuff, right? And what we wanted to do is we wanted to solve this problem. The more we thought about it, we realized this problem is all about metadata, right? And what do we mean by that? So the things we mean by metadata is what we call the ABCs. So the A stands for application context. This means information you and I need in order to be successful with data, right? This is like, does this data exist? What does it mean? Semantics, description, that kind of stuff. So table stakes, this is examples we just talked about. Number 2 is behavior. Okay, this exists, but who uses it? Can I trust those people, right? If it's some ops analyst, maybe I don't trust it. But if it's like a data scientist, maybe I trust it, right? So we often use these people who use it as proxy and the number of people who use it as a proxy for trust, right? And behavior can help with that. The third one is change. Okay, how has this changed? I remember reading this, but this column wasn't there about a month ago. It just got added. What does this mean, right? So how is this data evolving with time? And this is what we really mean with metadata. And so we embarked upon a journey to solve this problem, right? How do we capture this ABCs of metadata, and how do we bring them in applications to make our users more productive and make Lyft a more effective organization, right? So as you walk through with us in this presentation, keep these in mind. Like, we will talk about each of these ABCs and how we've tried to solve them. Okay, so the very first thing we did was asked ourselves some hard questions like, who are we solving this for? And the answer was we want to solve it first for analysts and data scientists. These are the people who use data most effectively, and they're the ones who are making decisions, which is where we want to invest the most. The next one, we divided them up into 3 different categories, right? So the first one is a power user. This is an example of Tao, been around 4 years, all information in their head, but get interrupted a lot in their job, right? How many of you get interrupted on Slack or something like that from new hires, like asking you questions, and you wish like there was a system that just gave them those answers, right? All of us. And then there are the noob users. These are people like who are just joined the company, smart people, but just don't have the context in order to be productive, right? And the third one is the manager types. Dependencies landing on time, making sure if your data is not arriving on time that you're letting you're communicating to your stakeholders that it's not arriving on time. So we focused on the first 2 kind, and we want to make sure that we reduce the number of Slack messages that get sent around asking for questions, and just it's the same questions over and over again. Cool. And then we asked people like what kind of questions did they want to get answered, and we divided them in 3 different categories. The first question is search-based, right? Like, I just want to do analysis on rides or cancels, and I just want to search where this information is. The second one is lineage-based. I want to modify this existing data model and add a new column, or I want to change the type of an existing column, heaven forbid, from int to a string, but I want to notify all the people so they know this is coming, right? And the third one is network-based. Oh, I just joined a new team. Tao is the team lead for that team. I just want to follow him and see like whatever he does in the organization so I can just learn what table he uses, right? Or I want to bookmark a bunch of tables that are good for me and then share those bookmarks with other people so they can learn from me and see like what tables I use, right? So these were the 3 kinds of questions we wanted to get answers to. Cool. Next thing we did an analysis of build versus buy versus adopt. So everyone's heard build versus buy. Well, what's this adopt thing? Like in this open source ecosystem of data, we always have the option of adopting an open source project, and that's what we wanted to do. So here's where we got with it. So on the left-hand side, the y-axis, you would see the criteria we use for the evaluation. This is super high level, by the way, right? So you have search-based queries, network-based queries, and lineage-based queries. And then some tactical things that we needed, right? We have a bunch of our data in Hive and Presto. We had a bunch of data in Redshift, and we wanted to be open source preferably. And then we put things on the x-axis. The horizontal side was things that were options for us. So there were vendors here. There was Warehouse, which is a LinkedIn open source project. Airbnb has a data portal, and then some open source and proprietary products, right? This slide is about a year late a year dated when we did the analysis. So it's obviously, like, new things may have come up that are not represented here. I'm not going to go through the matrix here, but the TLDR is, like, nothing really worked. The closest thing we got a lot of inspiration from was Airbnb's data portal. However, it didn't have Redshift support, and it wasn't open source, so we couldn't add it ourselves. So we really couldn't find a solution that met our needs. So the path we embarked upon was to build something. We built this thing called Amundsen. Amundsen is named after this Norwegian explorer with the same name who was the first person to discover South Pole. And we thought a data discovery project would be really cool to be called Amundsen. As it turns out, it's not a great name choice because people don't know how to say it or spell it or anything like that. But it's a clever name choice nonetheless. So let's move with that. The project is called Amundsen. Let's see what it looks like. So the first page is search, right? You want to come in and you just want to be able to search whatever you want to search. So say you're searching for rides data or cancels data or bikes data, you just type it in here. Now, if you are really new and you don't even know what to search for, we show you the popular tables in the organization. This is all made up, by the way. So none of this is Lyft's data model or anything like that. It's just names we made up. So we show you popular tables and you can just start browsing them and querying them. Also, today we only have data for tables, but this is going to expand to more and more different kinds of data resources really soon, and Tao will talk more about that. Anyway, you type for search, and we show you some search results, right? So the first 2 results we only show here, but in reality, you usually get like a couple hundred or so. Depending on what you search for, you get more than 2, right? You see some context about what the table is, and then you see the name of the tables. But let's talk a little more about how does a search work. So the first thing we want to talk about search is like, take example of a search engine like Google. You go, you search for Apple, right? If it shows you orange, that's obviously bad search because it's not relevant to you. But if it shows you an apple, that's a relevant search. But the other thing is maybe really you were looking for the computer company and not the fruit company, right? And so this is where popularity comes in. So popular results, like you all know, PageRank gets shown up earlier than non-popular results, right? And that's exactly the same thing we used in Amundsen, which means that when you see those search results, we use both the thing that you typed in the search box, but also the number of SQL queries that get written on the table, or if it's a dashboard, the number of views that a dashboard gets to power an algorithm to show those search results. So for the relevancy side, we use the table name, table description, and tags. And for the popularity side, we use the querying activity for tables, which is SQL queries written on a table, and we use dashboarding viewing activity for dashboards. We assign different weights for queries that are automated versus ad hoc. An ad hoc query by a human being carries more weight than somebody who just ran a scheduled job to query a particular table, right? Cool. So back to the mocks, we come back to the search algorithm, we search for things, we get some results. Now you click on a result, and this is where magic starts. So you have all the information about this table in one single page. So you have the rights data. The very first thing you see underneath it is 2 dates. This is the low watermark and the high watermark. The low watermark is the first date for which this table has data. The high watermark is the last day for which the table has data. In a real-time world, these would be timestamps, right? And then you see a list of columns in here. You see their types and you see descriptions. Now, descriptions are all editable, both at the table level as well as column level, and they get persisted. So anything you update here gets persisted. And on the right-hand side, we have a concept of ownership. This information is not stored in Hive Metastore or anything like that. It's stored in Amundsen itself. And people sign up in a manually wiki-style curated way as owners. But often, people don't want to sign up for owners. And what we do is we try to fix that problem by having frequent users. So we show the top 5 frequent users, if you see that over here. And this is people who query this table the most, and we put their names there. So if the table doesn't have owners, these folks add as a really good proxy for those owners. Next, so by the way, this is all the A of the metadata, right? So the application context, you see the columns and the descriptions and all, this is all A. But now when we talk about owners and frequent users, this is B, right? This is behavior, who is using this data, right? And then generated by is the DAG and Airflow that generated this data. This is also automatically populated. Source code that was used to populate this data, that's also automatic. And then table lineage is also how this table has dependencies upstream and downstream. That's also automatic. So most of the information you see here is A, B. We haven't really gone to the C yet, which is the change. Cool. So often you've done this, you want to see more, and you want to see what the shape of the data is, and that's where the preview functionality comes in. And you are able to click on that preview button, and it takes you to this modal, right, and see all the preview. Now, if you have permissions to see the data, you will see the data. If you don't have permissions, you will see something like this, right? And the last thing I wanted to show you was this. So if you click on a column name, you actually see some stats about the column. These are pre-computed, so it shows the count, the number of nulls, number of distincts, if it's a string, like length of the string, and so on and so forth. And this helps data scientists and analysts figure out what the shape of the data is, right? And helps really for them to understand if this is the table they want to use. So one note here, we have a feedback feature at the bottom, which you can just type in your feedback in the tool. One note, we want to talk about security in this context a bit. Our philosophy about this tool is that everybody in the organization should be able to discover what's out there. Whether you can use it or not, whether you can see it or not, really depends on the security team and your permissions, right? So you should be able to see what's out there, and once you decide this is the table you want, then you request access to it. In the future, we could see requesting access via this tool and then building that workflow over there. Cool. All right, with that, I'm going to pass it on to Tao to talk about how we actually went about building this.
Thank you. So let me talk about Amundsen architectures. So Amundsen is a microservice architecture, which includes 3 microservices and a data ingestion library. So we have a front-end services, which is used for user interaction for data discovery. A metadata service is used for serving the metadata request for front-end service. And also the search service for serving the search request from the front-end service. I will go into each of the components in more detail later. So first, what is a front-end service? So front-end service is written in React.js and Flask web framework, and is used for user discovery, for data discovery. So let's do a little recap from Mark about what is a Amundsen table detail page looks like. So there are a rich variety of forms of metadata. It shows the table names, the high watermark and low watermark of this table, and columns, column descriptions, column extend metadata like the statistics, and show the owners, frequent user, which FODAG. Also, it has been integrated with Apache Superset to allow user to see the data preview as well as the exploration, like you could run a lot of exploring SQL for this tool. All these metadata are powered by the metadata service. So let's move to metadata service. So the metadata service is a sync proxy layer to leverage the Neo4j as a graph database as a backend engine. So it's serving the metadata request from the front-end service as well as other microservices at Lyft. Currently, there's 2 microservices at Lyft are using our service. One is a machine learning feature service, which generate the features for machine learning training purposes. They are ingesting the feature tagging into our metadata graph to allow all these features for better discovery. The other will be the secure compliance service, which generates some security-related tagging into our metadata graph. So it's serving Neo4j as the default graph database, but we are working with the community to support using Apache Atlas as another option for backend engines. So when we're building the metadata, there are a couple of trade-offs we have made. The first one will be why we choose graph database. So to answer this question, let's do a recap about the Lyft data, typical Lyft data workflow. So application A, which could be a Lyft mobile client, so will fire events to B about, for example, the client's location. This event B will later on be consumed by streaming ingest framework C and write to a Hive table named D. Then our ETL framework runs some Afro DAC E, which reads table and writes to a derived Hive table named F. This Hive table F have 5 columns, G, H, I, J, K. Out of these 5 columns, 3 of the columns has been read by the user out. You could see this flow is very natural to model as a graph. And each of the components is a vertex and connected by edges. So in industry, there are other database offerings, like one is like NoSQL database like Cassandra or DynamoDB. They're good for performance, but they don't have good support in join, which is crucial to model the relation here. The other will be like the traditional RDMS like Oracle or MySQL. They do have join support, but their join performance actually will be degraded once the number of nodes have been increased. So in the end, we choose Neo4j, which is a popular graph database in this domain. So this diagram shows our actual metadata graph, which power that front-end table detail page. You could see the central node will be the table nodes, which connect with other nodes in the graph. Like for example, you connect with columns, you connect with the table description nodes, you connect with the watermark node, which showing the table's watermark, as well as which Afro DAC generates this table, which user has read this table, so on and so forth. So second trade-off will be, why not propagate the metadata back to the source? So Amundsen's mission will be like we try to remove the tribal knowledge and enable the data discovery for everyone. So before Amundsen is born, like Mark said, like newbie user will ask a lot of questions like, should I use this table? Is this column has been deprecated? And the domain expert like Mark will answer this question in Slack, and which will get lost in a couple of months later. So with Amundsen, we encourage the domain expert to update this kind of description through our UI to tell this table what's this table for, what's the column for. And this modified description come to a question, should we propagate this modified description back to the source? So the description initially is like a user write a GitHub source file, which later run by some Afro DAC will persist into Hive, and later will persist into our Neo4j graph. So once user modify the description, the question will be, should we propagate this description back to the GitHub source as well as Hive meta store? First, at Lyft, it's very hard to propagate this modified description into GitHub source, as every code change requires owner check, so it's not as easy as we thought. Then, should we propagate the change back to the Hive meta store? The first initial version of metadata, actually we did this. So we propagate all the modified description back to the Hive meta store. But this comes with a caveat here. So it doesn't work with a full rebuild table. At Lyft, we have about 20% of table are full rebuild, meaning that if you propagate this modified description back to the Hive meta store, it will get removed once the table is full rebuild. So in our initial version, actually we did just disable the full description modification for those tables. Then later on, users saying there's still a lot of value to enable the description modification for those tables. So in the end, in our second version, so we treat Amundsen as a golden source for metadata. And we never propagate the modified description back to the source. And you only pick up the description when the table is newly created from the table. So next, let's talk a little bit about the search service. Search service is also a sync proxy layer which leverage the Elasticsearch as a backend for serving the search requests. It supports like different search pattern, like normal search, basically like using the user input search query term, and then we match the record based on relevancy. And category search, we match the record based on data type, then relevancy, and then wildcard search. And when we're building search service, we encounter a lot of challenge. The first challenge would be how to make the search result more relevant. To answer these questions, we first define a search quality metric, because you cannot answer a question without a metric. So we use a metric called click-through rate, which is a typical metric in campaign, which we measure like the percentage of people click the top 5 results. And based on our analysis, we heard some complaint in our initial versions, people saying, oh, why I searched this table, it didn't end up in the first or second page, but end up actually in the 5th or 6th page. And some other user will say, oh, when I search this table, why it end up with an empty search result? And talking about that, we all analyze a lot of search results, and you bring up the second point, like search behavior instrumentation is very key for us to understand and improving our search quality. So based on this feedback, in the end, we make a couple of improvements. First is like we boost the exact table ranking. So meaning like if people searching the exact table name, the rank of this result will be ranked much higher. Second, we support the wildcard search. For example, user could type like event underscore star. It will show all the matching table with this. The third will be category search. For example, I want to know all the table with this column is underscore line rights. So you will search all the table with this column and return the result based on relevancy. So fourth, data builder. So data builder is a crawling framework to fetch the metadata from the source and persist into our graph. When we're building this framework, there are a couple of challenges here at Lyft. So first will be, there are many forms of metadata. At Lyft, we have like Redshift table, Hive table, AfroDAC, OLAP Druid, PostGraph, and Presto View. We also have like many dashboard tools like Apache Superset, Mode Analytics, and Tableau. So all these metadata, they don't have a standardization. So meaning like no single data model that could fit all the metadata. And it has different extraction mechanism. Like all these different sources are fetched differently. Like Hive tables store in Hive meta store. RDMS table like PostgreSQL need to fetch through some DB API interface. GitHub source code need to fetch some Git hook. And Mode dashboard need to fetch through Mode API. So to bring up the second challenge is like, how do we get this metadata? Should we use a pull model or a push model? What does pull model and push model mean? Pull model means like whenever there's a metadata update, it's not instantaneous update our data graph, while we have a fixed schedule job to kind of grab this metadata change and persist into our data graph. Push model means wherever there's a metadata change in the source will also send an additional message into a messaging queue, which later our near real-time framework will fetch this message and persist into our data graph. Pull model is good when you don't have a single interface for all the data. Or it's also good when you don't have a near real-time support. But it's hard to scale once you have many data. It's hard to scale with many organizations as well as many data sources, as you can write a crawler for each of these kind of metadata. So at Lyft, we initially start with the pull model because when we start building Amundsen, we don't have a reliable infrastructure Kafka setup. And now we are moving to a hybrid model, meaning like we are combine like pull model as well as push model. So what is our data builder frameworks like? So it consists of 4 phases: an extractor, a transformer, a loader, and a publisher. This framework is highly inspired by a popular data integration framework called Apache Goblin. So the extractor will fetch the record from the source and pass to the transformer. The transformer will transform the record into the target form and pass to a loader. Loader will load this record into a staging area and then later pass to a publisher to persist into the sink. Here is an example. We try to fetch a record from high meta store and persist into Neo4j graph. You will use a hyped metadata extractor, which is a subclass of SQL Alchemy extractor to fetch the record and pass to the no-op transformer because we don't need any transformation in this case. And then pass to file system Neo4j CSV loader to generate serialized CSV files. Then later will be used by the Neo4j CSV publisher to publish the record. So here is an example of how this job looks like. At Lyft, we use Apache Airflow to do the orchestration or Amundsen because Airflow is a popular workflow management and known for dependency management. So when this job is kicked off, we want to kick off in some certain sequence first. Like for example, the metadata job need to kick off first. Once it's finished, we'll start the extend metadata collection like table stats, high watermark, low watermark, which DAG generated. And once everything is finished, you will kick off the finished job, like publish the last update timestamp into a graph, which showing the data freshness of our metadata. So what's next? So at Lyft, Amundsen seems to be very useful and has been used by many different personas. And even custom service has used our tool. And we have seen there are many organizations actually facing this kind of similar problem. And in fact, actually we work with other companies like ING, WeWork and more. And we plan to announce open source of our tool very soon. And talking about the impact at Lyft, like here is a weekly active user for this tool at Lyft. We call it the MBA graph as it doesn't have a y-axis. So when we initially do the alpha launch, we only make it available to some early adopter. So you can, and this is the alpha release. We refine and improve the tool based on the user feedback, and then we move to the beta release, which is internal. We see a huge jump. And then we refine and improve the monitoring and also improve the reliability of this tool and make it GA release. And we see a huge jump. You could see some dip here because it's around Christmas and nobody worked at that time. and we're seeing a steady growth of these tools at Lyft. So what's the next? So in our phase 1, we are adding the table resource. That's also complete. Now we are working on adding dashboard and people to enrich our metadata graph. Once those are finished, we plan to add like Kafka stream, IDL schema, as well as ML workflow and Airflow DAG into our graph. To summarize, so data discovery could add 30% more data productivity to our data scientists. And we believe like metadata is the key to the next way of this big data ecosystem. And Amundsen has this mission, it's a Lyft in-house metadata and data discovery platform. And please do check out our blog post about this tool. And we also have the slide here, like the go.lyft.com data discovery site, as well as the blog post go.lyft.com data discovery blog. Thank you.
We got time for questions. Yes, sir?
So everything is automated the way you populate the catalog, or you also use human beings to add more information to it? How do you actually pick which tables and data sets out of all the universe of data that you guys have should be in the catalog versus things that are going to be deprecated, are not worth it to have in the catalog?
Yeah, okay, good question. So there were 2 questions there. The first one was, what information from this page is automated versus manually populated? And the second question was, how do you figure out which information would you index versus which one you want to keep out? Yeah, is that fair? Okay, so first question. Most of this information is automated. That's on the right side. So the information about frequent users, the code that generated it, the DAG that generated it, table lineage, preview, and explore is all automated. The things, and the high watermark and the low watermark is also automated. The things that are not automated is the knowledge that people have in their head, right? So what's knowledge? It's like, oh, does this column mean like, is like is this cancel time, or is it like the time when you requested the cancellation of the ride, right? And so the intent of the columns is not represented automatically, and that's the wiki-like functionality. So you click, you see that it's not, this is an old mock, but if you click on the right side arrow, which points down, there you can edit the description. Same thing for the table description. So description and the owners are the only thing that are not populated.
Also the taggings. So there's also like we add the tags to allow certain table to be grouped into certain category to allow better discovery.
Yeah. About the second question, how do we decide what we should populate? That's an interesting one. Actually, it's something that we learned the hard way. So we started off asking users which things they cared about the most and where the most pain was to populate them. We got a list of schemas and databases that we wanted to aggregate. But now, as we are trying to build new applications, and I think this would be a good thing to talk about too, what we have done as a part of this exercise, we've built a repository of really rich metadata, right? Historically, this metadata has only been used for productivity reasons, but we were realizing if this metadata was comprehensive, we could use it for other applications. So what are some of the other applications we could use it for? One could be compliance or GDPR, CCPA kind of business, right? If we know where all the data is in the organization, we know all the columns, we can tag the columns as personal, non-personal, and we could use that to govern our data, right? And so as we do that, we have a need to actually be more comprehensive than just what we would do for productivity. So for productivity, it was just like, tell us which things you care the most about, but I think we have to, and we are already embarking upon being more comprehensive and just indexing everything. Yes, ma'am?
How do you decide that someone's domain expert description or metadata update is worth taking versus when not to take it? And how do you adjudicate?
Yeah, good question. So how do you moderate a comment that got added to make sure it's credible? We had the reverse problem. People weren't updating comments, and we just opened the floodgates. And we said, well, we'll deal with the problem of having non-credible comments if we come to it. We haven't gotten to that. So right now, the floodgates are open.
So to comment that is like, actually, we have a very good instrumentation for everything. So for example, which user searching which term, adding which column, adding which owner, we all do instrumentation. So we plan to add a feature to say if user put as an owner, once a column of table description has been updated, this information will also send an email to the owner to see if this makes sense or not, something like that.
Yes, sir?
How do you measure how it's solving the problem? Is it actually using less questions in Slack?
Good question. So the question was, how do you measure if this is actually solving the problem? First of all, I'm glad you're not my boss, because that's a very difficult question to answer. But to answer your question, I think what we can measure is people are using this tool, right? And to truly answer your question, we don't know if this is actually solving the problem, so we have to go get some qualitative feedback. Do we have any Slack messages that we can share with the people here in the Slack?
I'm not sure we could share.
People are just all over the place yelling and loving this tool, and that's probably the only data we have to show that it's actually working. I want to go to the left side here, sir.
Yeah, two quick things. One, I'm curious if you can share roughly how many engineers you had working on this. And then the second question is, could you maybe provide a little one click down of detail on the web crawler component about what technology you use and how you built that?
Sure. So for the first question, how many engineers? So we have about 4 engineers, like 2 front-end and 2 back-end engineers. And for the second question is what's the technology we use for the data builder? 1 second. You mean this one, right?
Yes.
Sorry. So we mostly just Python. So it's like, so we keep into different phase. Each of component will have an extractor, transformer, loader, and publisher, and will be a different kind of packages. So you could just build your own package, follow certain base interface we define. Yeah. Does it answer your questions?
Yeah, that's good. And do you also schedule all of these tasks inside of the Airflow department?
Yeah.
Okay. That was really my main question.
Yeah.
Thank you.
Cool. So, but it doesn't mean you need to use Airflow. You could, because these are all Python files. It's same as when we use. I'm not sure everyone have Airflow background. We're using the Python operator to schedule this job. You could just write some cron Python script to call this job as well. Yeah.
Out in the back somewhere, any questions? You, sir?
Yeah. So one of the biggest problems that we face is stale data. Is there a way to flag tables that appear to be stale data or set a TTL on any of that?
To answer this question will be, is there a way to flag the table is stale data? We do, actually. Initially, we don't have this mechanism, so people say, oh, I create this test table. It should be deleted. Why is it still showing in the graph? And in fact, actually, come to our attention, and then we set some TTL in the metadata, and will get deleted at a certain point. Yeah.
You, sir?
I'm curious, early on in the development of this within your organization, some of the challenges you went through in order to sell it to the business, and also if you have any advice for people who want to do something similar.
Yeah, so the question was, what were organizational challenges that we went through in order to sell this to the business? I think that would depend differently from organization to organization, but most of it is fairly standard, not specific to this tool. It's like being able to quantify the impact and have your users, your potential users, ask for the tool, then you ask for it yourself. It did not get prioritized the first few times we asked, but then eventually it got prioritized and it happened. Did that answer your question?
Yeah.
Okay. You missed.
Was there any one particular thing that you would say that is the point that reduced management or users to use it? Was there anything that you would say this was the one that solved it?
Yeah, the question was there one thing that convinced management or users to use it? Yeah.
So let me take this question. We at Lyft, we don't have this kind of tool, so it's more like a homegrown. So user has been asking how to make the data describe more. So we don't see a lot of broker in this case. Yeah.
Can we do one more question, or should we just? Okay, one last question, you sir here.
Do you guys have any new ideas around data lineage or provenance, particularly on offspring objects?
Okay, so the question was new ideas on data lineage and provenance.
So for the tools, you will see it has an additional link connect to a table lineage tool. So in fact, at Lyft, we have a different tool to provide the data lineage. Right now, we are just serving that tool's UI for this table. So we do plan to integrate deeply with that tool to bring that information table upstream, downstream into our graph to directly show into our table UI.
Cool, that's all. Thank you very much for attending. We really appreciate your time.